An effective 3D robot guidance system is the key to revolutionize the current machine feeding strategies of which flexibility is compromised by a completely rigid mechanical periphery. ISS, spin-off of the Milan Polytechnic, and 10 projects have manufactured an innovative tridimensional robot guidance system named 3D CPS. It holds in a single unit all the measurement and analysis functionalities needed to identify the poses of parts disposed at random in a bin and to allow all robot systems to perform their picking. The measure of the scene is carried out by means of a pre-calibrated laser scan. The embedded intelligence processes very quickly the acquired data thanks to a software of which core is a robust 3D pattern matching algorithm. 3D CPS can be easily integrated in any robotic cell and performs all the complex bin picking tasks. The user has just to provide the system with some relevant information about the part geometry and to gather the pose of the part to be picked by means of an open TCP/IP communication protocol. This was conceived in order to guarantee the compatibility with all robot models. It's worth highlighting that 3D CPS does not increase the cycle time, as the data processing is always performed while the robot is busy loading the tool machine. The system is able to recognize with a very high reliability the side and the phase of the part to be picked, so as to allow the robot to correctly load the machine. 3D CPS is able to recognize the non-complying parts, highlighted in yellow in the video, and allows the user to manage a possible condition which no one part may be picked. The system is also able to distinguish mixed parts in the same scan. In such a way, it's possible to deal with more kinds of objects or possible production wastes within the bin. A very relevant 3D CPS point of strength is the wizard procedure, based on a dedicated tridimensional renderer that enables the line manager to create and insert their own 3D models to autonomously handle new products. Such models may be obtained from either the Part 3D CAD model or its scan that can be carried out by means of the 3D CPS itself. Moreover, it's possible importing the robot tool 3D CAD model, both to define the part picking zones and to identify the areas where the superimposition analysis has to be performed. In fact, it's necessary to specify which regions must be clear of other parts or obstacles, in order not to compromise the success of the picking. ISS and TEN projects, faithful to the philosophy of continual product improvement, now proposes an automatic planning model of the robot trajectories during the collecting operation. This model supports and completes the 3D CPS in drive operations in the presence of obstacles and overlapping parts. In these operations, the ability to determine, in a very accurate way, the drive positions is not sufficient, but it would be useful to have an automatic trajectory generator able to calculate a robotic route free from collision. 3D CPS is the best solution for all those system integrators which intend achieving modular and reconfigurable solutions by making the most of the flexibility offered by robot systems, which is currently limited by the traditional feeder equipment.